What if you could generate complex, organic, parametric architecture inside SketchUp with just one click? No massive Grasshopper setups, no hours spent aligning tedious components, and zero manual geometry cleanup. What you just saw took exactly 1 second to build, and I didn't model a single louver. Welcome to video 3 of our AI in SketchUp automation series. Today, we are pushing the Ruby console to its absolute limit, using advanced AI logic to generate responsive parametric facades and complex twisted louver walls instantly. To find Ruby console, just head up to Extensions, hover over Developer, and open the Ruby console. If you are on an older version of SketchUp, it might be right under your Window tab. If it's not there, you can download it from the SketchUp Extensions webpage. This console is the back-end brain of SketchUp. It lets you alter or build 3D geometry using code.
For our first design, we want a highly responsive sine wave louver facade that adapts perfectly to whatever face we select in our model. Writing this kind of dynamic geometry from scratch requires serious coding knowledge, unless you know the meta prompting workflow. But how do we get a prompt that's precise enough to write clean code? Simple. We use AI to prompt AI. Now, to create the detailed prompt, first I went into Gemini and gave it my raw architectural parameters and outlined the geometric logic, a sequence of vertical wooden fins that scale their depth based on a mathematical sine wave pattern across the selected face's width. Gemini takes that prompt and converts it into a flawless, logic-mapped developer blueprint, an incredibly detailed developer prompt. Now, we take this exact prompt and feed it into an AI coding agent. We can use any AI coding agent, such as GPT, Claude, or Codex. I'm using Codex in this example.
We take this blueprint and feed it into Codex, the absolute king for rendering complex, multi-line structural code. Within seconds, Codex delivers our clean, optimized Ruby script. Let's test it. Back in SketchUp, all I have to do is select the base face, open the console, paste the script, and hit Enter. Look at that! The code automatically detects the face's orientation, sets up the bounding loop, and arrays the louvers in a stunning, fluid wave pattern. It perfectly follows the mathematical logic, creating high-end parametric architecture inside a basic SketchUp viewport. It is incredibly simple, and it works flawlessly on any face you choose. But let's take it a step further. What if we want something even more advanced, like a complex twisting brick facade? For this, I gave the parameters directly to Claude. And again, Codex delivers our clean, optimized Ruby script. We copy the generated script, head back to the console, and hit Enter. We hit an API error.
The Ruby console threw a syntax exception, but don't panic because this is where the workflow becomes truly bulletproof. You don't need to know how to fix the code manually. We just copy the raw error code straight out of the console, paste it back to Claude, and say, "Fix this." Claude instantly catches the API mismatch, optimizes the geometry loops, and gives us the updated script. We copy the clean code, paste it back into Ruby, and look at that! A perfectly arrayed, fluidly twisting parametric brick wall. Absolutely magnificent! This is the real power of combining architectural intuition with AI logic. You aren't just a designer anymore, you are a digital engineer directing software to build your vision instantly. We are gearing up for the launch of our massive automation masterclass, where we will break down workflows that will completely change your architectural production speed.
Hit that subscribe button so you don't miss it. Drop a comment on which facade you liked better, and I'll see you in the next video.